In this video, we will be looking at sequences, conditionals and loops once again and use flowcharts to get a better understanding of these three basic structures. First, let us look at what a flowchart is and the most common symbols used in them. Flowcharts, as we know, is a graphical representation of an algorithm. So this is how a simple flowchart looks like. In this, we have this oval shape. This denotes the start and end of the program. Next is this rectangle, which will be used the most. It denotes the process steps to be carried out. So, any process you do in your program like addition, subtraction or swapping of numbers, changing values, all are written in these rectangular boxes. Then we have these diamond shaped decision boxes. Whenever our program needs to make a decision, we write the decision question in this diamond box. The answer to the question in this diamond box should always have either a true value or a false value. Or we can say the answer should either be a yes or a no. And based on the answer, the program will continue along one of the two paths. Apart from these, we have one more symbol, the input symbol, which we will discuss later. So now we will try to understand our programs using these symbols. Let us first look at the sequence structure once again. So we know that in a sequence, actions are performed in order and there is no branching or skipping of any task. So we will begin with the start button and just go doom, doom, doom and continue step by step until the sequence ends. So you see in this flowchart there are no branches, just step A, step B, step C and N. Next is our conditional structure. It is also called a selection structure. As we know that in a conditional structure, we ask a question and based on the answer to that question, we follow a path. So, a flowchart that describes a conditional structure must begin with a decision symbol, which is our diamond shaped box. And we write our condition in this diamond box. Conditions can be like any question which has only two answers, yes or no. Like in our previous video, it was does the person like tomatoes in sandwich or not? The answer is yes or no. Or is it raining? Answer is yes or no. Is A greater than B? Answer is yes or no. So we write our condition in this diamond box and from this diamond box emerge two branches or paths for the two answers. One is followed if the answer is yes and the other if the answer is no. So if some condition is true, like if A is greater than B, then do one process. So we can say if A is greater than B, then print A, else we do another process, that is print B. The branches that emerge out of the diamond box, they join at the bottom like this and this completes our conditional structure. Whenever we want to write a condition, we will use this structure. And next is our loop structure. A loop structure repeats a series of actions while a condition remains true. So we know that sometimes we need to repeat something over and over and over again. So instead of writing hundreds of millions of lines of code through repeating the same lines over and over again, we put it in a loop body. And the action or actions that occur in a loop are performed again and again till the condition is true. These conditions are the same as we saw in our conditional structure and have only two answers, yes and no. Only difference is that in a loop we will keep doing the process again and again until the condition is true, while in a conditional structure we did it just once. So we will enter our loop with a condition which is first tested, and if the condition is true, then we execute the steps in the loop body, and after executing them we come back to the point where we tested the condition. Here we again test the condition and if it's true, we execute the loop body again. And we keep doing this over and over again while the condition is still true, only exiting the loop when the condition is false. As in our last video, we needed to make 4 sandwiches. So our condition to enter the loop will be, do we need more sandwiches? Yes or no? Yes, enter the loop and make a sandwich. Come again and test. Keep doing this 4 times and after 4 sandwiches, the answer to the question, do we need more sandwiches? Is no. So we exit the loop. Now comes something important. Why we have been learning these basic structures in this much detail? It's because all the logic problems that we will be facing can be solved using only sequence, conditionals, and loops, and they can be combined in an infinite number of ways. We just have to imagine them as boxes and stack them one over the other as shown. So here, as you can see, we have a sequence. Sequence is followed by a condition, and after condition we have a loop. So this is just one basic form where we have combined a sequence, a condition, and a loop. Soon you will see that there are so many other forms also in which you can combine these three sequences, selections, and loops. Here comes another example. In this we have a condition, the if condition H is true, then we go into a sequence. We follow step J, and after that we go into a loop. While condition K is true, we do a loop structure, and after coming out of loop we again go into a sequence and we come out of the condition. Any individual task within a structure can be replaced by a structure, placing one structure within another. It is important to know the start and end of structures. Like, how do we know where the while starts and ends? So we indent the code, and then we get a block, which is a group of statements that execute as a single unit. Some languages have block delineation symbols as well. For example, Java and C++ use curly braces to identify blocks. So here we have got a conditional structure, and within our conditional structure we have a sequence. So step J, while loop, and L constitute as a block, which is a group of statements and that execute as a single unit. They come in one line. They are aligned, and if and if are aligned. Now we will take a look at some flowchart examples and try to understand them. But before doing that, let's look at the input-output symbol of flowchart that we mentioned earlier. This is the input-output symbol of the flowchart. It is used whenever we want to have an input from the user or give some output to the user. Here is the algorithm and flowchart to find sum of two numbers. This is the algorithm and this is the flowchart. The algorithm will be start, input the numbers, first number, input second number, find the sum is equal to a plus b, and display sum. So when we put it into a flowchart, it looks like this. Start, input value of a, input value of b, sum is equal to a plus b, print sum, stop. So as you can see, this is a sequential flowchart. And these parallelogram boxes we have seen are the input boxes. So for both input and outputs, we will be using these parallelogram boxes. This is the algorithm and flowchart to find the larger of two numbers. To find the larger of two numbers, first we will need to input the two numbers, and then we will compare the numbers, and based on the result we will print which one is larger. So let's look at the flowchart. Here we start and input number 1, then we input number 2. Please note that here we are assuming that num1 is not equal to num2. So after inputting the two numbers, in the diamond box we will write our condition. Our condition is if num1 is greater than num2. So if num1 is greater than num2, then this statement becomes true. So if num1 is greater than num2, then we will print that larger is num1. And if num1 is not greater than num2, it means num2 is greater than num1. So in that case, we will print that larger is num2. This is an example of a very simple conditional flowchart. Now this is our last flowchart. Let's look at this one. This will print numbers 3, 2, 1 on the output screen. This will help us understand how a loop really works. We start here, and to print out values 3 to 1, we have used a variable I. So we have declared a variable I and we have assigned it a value of 3. After that, we come to the condition which is tested for entering the loop. We are checking the condition, is I greater than 0 or not. Here, as we know, right now I is 3 and 3 is greater than 0. So the condition is 3 greater than 0 is true. Therefore, we will go inside this loop and print the value 3 on the output window. After that, we decrease the value of I, so the value of 3 now becomes 2. And after decreasing the value of I, we again check the condition that is I greater than 0 or not. Right now, the value of I is 2. 2 is greater than 0. So, yes, it is true. Since the condition is true, now we again go inside the loop and simply print the value 2 on the output window. Right? Now, after printing the value 2, we decrease the value of I again and make it 1. Now, we again check the condition is 1 greater than 0 or not. As 1 is greater than 0, which is true, therefore we simply print the value 1 on the output window. After printing the value 1, we again decrease the value of I, which makes I 0. Now again we check the condition is 0 greater than 0 or not. 0 is not greater than 0, right? That means it results in false value. If the condition returns false, then we don't go inside the loop. The final output is 3, 2, 1, which is what we wanted.